All right, let's take a look at lesson 10.2, area of trapezoids, rhombuses, and kites. All right, so here, our first formula. Now, one thing you make sure you want to do is on your paper, you want to make sure that you rewrite it and put a plus sign in between base 1 and base 2. So the area of a trapezoid is 1/2 the height times the sum of your bases. Remember, we learned about parallelograms. The bases are the ones that are going to be parallel to each other. Okay, and the height is the distance between those bases. And once again, the height is always perpendicular to your bases. So let's take a look at example 1. Find the area of Nevada. So what is the approximate area? Well, it's approximate because these are all rounded off answers, plus Nevada is not exactly a trapezoid, but it's very close to it. So let's take and apply our formula. Now I want you guys to get, especially now, get in the habit of writing your equations down and identifying each variable. So once again, it's a trapezoid. Area is equal to 1/2 the height, base 1 plus base 2. So we have the height to identify, base 1 to identify, and base 2 to identify. The height here is the distance between our bases, and we're going to say that 309 is our height, the distance between our two parallel sides. So 309. Base 1, doesn't matter which one you call base 1 or base 2. I just usually pick the top one here, or this one on the left, the smaller one, so 205 miles, and then the other base will be 511 miles. So next it's a matter of plugging our information into our equation. 1/2 of the height, which is 309, times the sum of our bases, which is going to be 205 plus 511. So we're going to add these two numbers together. That gives us 716. Bring down the 309 and the 1/2. Now you could do this on your calculator. So at this point we'll take this, our calculator. I say that, we will. There we go. And we're going to do 1/2, so we can do 0.5 times 309 times 716. And so our area is approximately 110,622 square miles. Wrote that a little backwards there. We got miles squared. Okay, so it's a matter of taking your information, plugging it in, and you get your answer. Nice and easy. You guys calculate the next one. What is the area of the trapezoid with height 7, bases 12, and 15? Round your answer to the nearest square centimeter. So pause your video now and come back and check your answer when you're done. Alright, so let's look at the area here. We have the area equal to 1/2 the height times base 1 plus base 2. Now most of the time we have to draw our picture, but in this case here they give us all the information. The height, the two bases. So height is 7, base 1 is 12, base 2 is 15. Plug our numbers in. 1/2 of 7 times 12 plus 15, which is 1/2 of 7 times 27. And we multiply it out and we get 94.5, and it says round to the nearest square centimeter, which means it's the nearest whole number, and we get 95 square centimeters. Alright, so let's take a look at using our formula a little bit differently now. What is the area of the trapezoid PQRS? Leave your answer in simplest radical form. Alright, so once again we have a trapezoid, but our information is we're missing part of it. So let's see which part we're missing. So once again we write down area is equal to 1/2 height, base 1 plus base 2. So we have a height, base 1, and base 2. Those are our variables we need to identify. Now the height, we don't have it. We're looking for the height here, the distance between our bases. Now this didn't come out right, but that is a right angle here, which means that these are right angles here. So the height of this trapezoid we don't know, which means we're going to have to find it. Base 1 I'll let be 5, and base 2 we'll say is 7. So in order to find the height, we're going to use our trig. or special right triangles. So what we're going to do is we're going to draw our height across here. So we got to figure out what can we use to help find this height. They give us the 60-degree angle, which is this angle right here at angle P, 60 degrees. So that means that because this is a right angle, this is also a right angle here, which means we have a 30, 60, 90 right triangle. Now, if you remember back to the trig, a 30, 60, 90, 30 degree here, 60 here, right angle, this was going to be 2 in, this was in, and this was in radical 3. So, if you look at this triangle here, we know that this side, we don't have any of these sides, but if you notice here, by drawing this line, we created a rectangle. It has a length of 5 here, which means from here to here is also 5. So if this whole thing is 7, then we can do 7 minus 5 and get that this segment from here to here is going to be 2. So now we have our short leg of our 30, 60, 90 right triangle, and that's the key, which means that our height is going to be whatever this leg is times radical 3. So this will be 2 radical 3 based on our patterns here. Now we didn't have to know this, but we can say that this side right here was double 2, which is going to be 4. So we have 4, we have 2, this is 2 radical 3. So that means that our height is 2 radical 3. And they ask us to write these in simplest radical form. So we take our equation, plug in our variables, 2 radical 3, and we get 5 plus 7. So that becomes 12 times 2 radical 3 times a half. Now, the half is on the bottom here, so you can make these all over 1 if you needed to help you know that this 2 is in the denominator. It can cancel with any even number up top, unless it's inside the radical. So 2 goes into 2 once, and that means we're left with 1 times radical 3 times 12, all over 1, 1, and 1. So our answer is going to be 12 radical 3. Now our units here, go ahead and add that in here. Our units are going to be meters squared. So we get 12 radical 3 meters squared. So make sure that we draw this line here to help identify our height. So let's go to the next one. Imagine if we took this same drawing, except for instead of being a 60-degree angle, we had a 45-degree angle. So let's take a look at what this figure would look like. You've got two sides that would be parallel, one longer than the other. I realize this is a little bit longer than the other one, but it'll serve its purpose here. We have the right angle here. We said this side was 5, this side was 7. And this time, when we draw the height here, we have a 45-degree angle in the corner. Now, same rules apply. This is 7 here. This is going to be 2 here. Now, because it's a 45-degree angle, this is a right angle. That means this is also 45. So we have a 45, 45, 90 right triangle. And if you remember, in a 45, 45, 90, the two side lengths were the same. And the hypotenuse was whatever the side length was times radical 2. So this is 2, this is 2. This means this is going to be 2 radical 2. So the legs are the same, so if this is a leg, this is also a leg, which means my height is 2. So as we write our formula down, we get 1/2 height times base 1 plus base 2. So we got our height is equal to 2, base 1 is 5, base 2 is equal to 7. So area is equal to 1/2 our height of 2, and we know 5 plus 7 is going to give us 12 from the last problem. So we got 12 times 2 times 1/2. 2 cancels, that leaves us with an area of 12. Now our units here were the same. The last one, which means that these are going to be meters squared. So the area is going to be 12 meters squared. All right, so let's move on to rhombuses and kites. Actually, before we do that, let's take a look at example C. This is not on your paper, so you can draw this. So in this case, we have a 60-degree angle. They give us this base is 51. They don't give us the base up here. And they give us that this side of the trapezoid is 24. So I want you to try to figure out and find the area of this trapezoid using a right triangle. So pause the video and see how you do. So let's finish filling this in together and see how you did. So your height, we don't know. It's not given to us. We also don't know base 1. So we got to find two things here. We're given base 2. If this is 24, then this means that this side is the hypotenuse, which is equal to 2n, which means that the short leg is going to be half of that, which means this is 12. Therefore, this side is going to be whatever this short leg is times radical 3. So we get 12 radical 3. So we write that in over here. 12 radical 3 is our height. Now, if this is 12 and this whole length is 51, that means that this distance is going to be 51 minus 12. And so 51 minus 12 is going to give us 39. So this means that our other height, our other base is going to be 39. So we have 39 now and 51, so now we can go back and calculate our answer. So we're going to leave this in simplest radical form again. So we get 1/2 of 12 radical 3 times 39 plus 51. So as we add these two together, that gives us 90. It's the sum of our bases. We have 12 radical 3 and we have 1/2. So the half I can take of any even number, so this goes in here 6 times. And now we get 6 times 90. That's going to give us 540. So we get 540 radical 3. Bring the radical 3 down, and this is meters squared. So this is an exact answer. Nothing's been rounded off. Everything's been calculated. All right. Let's go to the next. Area of a rhombus or a kite is half the product of the lengths of the diagonals. Now, some parts did not show up here, so I've kind of drawn them in. You may have to draw them on yours. This right here is referring to diagonal 1. This is referring to the length of diagonal 2. Now, this is referring to the entire length of the diagonal. This is diagonal 2 right here. This is diagonal 1, the one in blue. This is diagonal 2 here in a kite. And therefore, our equation is 1/2 diagonal 1 times diagonal 2. Very easy formula. And remember, because a rhombus is a square, we can also use this formula when we're finding the area of a square. It'll become useful in some of our later lessons in chapter 10. All right, so the first one, example 3a. What is the area of kite KLMN? So, first thing we're going to do, and let me redraw this picture here, let you know what this number 2 is referring to. We're going to write this is a kite, so the area is equal to 1/2 diagonal 1 times diagonal 2. A lot of people forget this is diagonal 1 times diagonal 2. No plus or minus, just all multiplication. Diagonal 1 is equal to the distance of KM. So let's call that KM. We'll call diagonal 2 LN. Now KM is going to go 2 plus this distance here, which is going to be 5. So that gives us a total of 7. LN is going to be 3 plus 3. That's going to equal 6. So the area is 1/2 of 7 times 6. So that means this can be 1/2 of 3, and that gives us an area equal to 21 meters squared. So the entire length of the diagonal, which means you may have to add up the full length. Sometimes they may give it to you, sometimes they may not. So make sure you pay close attention to what they've given to you. All right, you guys find the answer of this one. What is the area of a kite with the diagonals that are 12 inches long and 9 inches long. All right, so let's see how you did. Area is equal to 1/2 diagonal 1 times diagonal 2. First area is 12 inches. Second diagonal is 9 inches. Multiply them together, take half of that. That gives us 54 square inches. All right, so let's take a look at one where we have to use our trig. Again, the HOV lane is marked by a series of diamonds or rhombuses painted on the pavement. What is the area of the HOV lane diamond shown on the right? So I'm going to redraw this so we can kind of draw on it here again. I'm going to draw the diagonals, make it a little easier to see. So this is a rhombus. Now remember, in a rhombus, the diagonals are perpendicular to one another. They also bisect one another. And this doesn't look quite like a four sides the same, but we're just going to say it is for this one. So this is A, this is C, this is B right here. This distance is 2.5 and this distance is 6.5. So we have area equal to 1/2 diagonal 1 times diagonal 2. So diagonal 1. We know diagonal 1 is going to be that this side BC is 2.5. That means that this side is also 2.5, which means diagonal 1 is going to be 2 times 2.5, which is going to be 5. So 5 feet would be our first diagonal. Diagonal 2, we don't have any part of it, so we have to find it. Now, this is 2.5 here, and therefore we have a right triangle. We have two sides of a right triangle, so we're going to use Pythagorean theorem to find our third. So we'll call this x here, which means this distance down here is also x. So we get x squared plus 2.5 squared is equal to our hypotenuse squared, which is 6.5 squared. Now, 2.5 squared is going to be 6.25, so we have x squared plus 6.25. 6.5 squared is going to be 42.25. Now we're going to subtract 6.25 on both sides. That gives us that x squared is equal to 36. Now we'll take the square root of both sides, and x is equal to 6, which means that this length is 6, which means this length down here is also 6. So 2 times 6, which gives us 12 feet. So now we have both our diagonals. So area is equal to 1/2 of 5 times 12. 5 times 12 is 60, so half of 60 will give us 30 square feet. So the area of this one diamond is 30 square feet. All right, so let's take a look at one more. This one here, here's the information they give us. They give us that this angle is a 60-degree angle. This is 4 meters, which they're pointing to right here. This is the length of this diagonal here. And this is a rhombus. So remember, this is a right angle. These two bisect each other, so we want to find the area of the rhombus. So pause your video, try this, and come back and see how you do. All right, so we have a 30, 60, 90 right triangle. And these bisect each other, so these two will be the same. And these two will be the same. So if this is 4, this is 4 over here, which gives us our first diagonal of 8. This is our short leg because it's across from the 30. So that means that this longer leg is 4 radical 3, which means this leg down here is also 4 radical 3. So multiply it by 2 and get 8 radical 3. So that gives us our second diagonal. So we plug it into our formula. And I take half of 8, which gives me 4. 4 times 8 is 32, and we bring down the radical 3. So we get 32 radical 3 square meters as our area of this rhombus. So this concludes lesson 10.2, area of trapezoids, rhombuses, and kites.